So, Chapter 2, Section 1. Solving equations by adding or subtracting. You've done this. So this should be all review. I'm going to try to go through it pretty fast. If you're like deer in the headlights, holler. Fair enough? A couple definitions first. Equation is really just when you have something equals something. That's kind of the low budget version, but it's something equals something. In other words, you have to have an equal sign, and there's going to be something on either side of the equal sign. So if you wanted to put down examples, you could say like example, x equals 4, or 5 equals 5, or something like that. You just need to have an equal sign and something on both sides. Good? Then the solution of an equation is what the variable equals. So what the variable equals. And I'm going to jump down the page a little bit. So in other words, when we have this thing here, x plus 5 equals 14, the solution to that is going to be what number could you put in for x that would make that number plus 5 equal the 14. So that's kind of what we mean by solution to an equation. What number would fit for the x? These here, don't memorize them. I'm just trying to put them in front of you again. You saw it in Math 8. Maybe you totally forgot it. You're going to see it a ton in geometry next year. But they say this addition property of equality. What they're really trying to say is this. I'm going to write it in numbers first. If you have 5 equals 5, do you agree that's true? 5 equals 5? Yep. I need a number. Anyone?
14.
5 plus 6, it's shorter than 14, equals 5 plus 6. Do you agree I could add 6 to both sides? That's what this is trying to show. It's trying to say, well, for all real numbers, so A, B, and C are just going to be numbers. If you have, say, 5 equals 5, then 5 plus 6 is going to equal 5 plus 6. Fair enough? That A is 5, B is 5, C was our 6s. We could do that same thing for subtraction. If you have one number equals itself, probably, or something equals something, if you subtract the same amount from both sides, it's still going to be equal. Agreed? Those names, being able to define them, that's going to come up more next year in geometry. All right, so now solving equations. Here's kind of the Falk version of the truth. Look at what was done to the variable and do the... technically the math word is inverse, but you're totally right. Most of us look at it as though opposite. I'll squeeze them both in there. Oh, the opposite goes in my parentheses, opposite. Sorry about that. Yeah, for years I looked at it as opposite. Technically it's the inverse. We do the inverse or the opposite operation to both sides. So do the inverse operation to both sides. And addition and subtraction are inverse operations. A lot of us kind of think of it like opposite. Like, what's the opposite of adding 5? It'd be subtracting 5. You know, the opposite of giving somebody $5 is to take away $5. But technically the math word is inverse. I would really encourage you to do these this way. And I'm going to ask you to show your work on your homework. Here's the short version of the truth. I helped a guy named Dave in Algebra 2. Dave was barely passing Algebra 2. It was about partway through the year. And I was helping him after school one day. It's the first time I really worked with him one-on-one. Like during class, he would not really want help at all. Finally, he comes in. And I'm kind of expecting Dave to not be very good at math. You know, he's a sophomore. He's in Algebra 2, so he's in advanced math. But he's really struggling. And it turns out, as we're working together, he's doing math in his head faster than I can do math in my head. Like adding 2 3-digit numbers, some multiplication stuff that's hard, like, I don't know, 12 times 14. It's like he's spitting out answers faster than I can. It's like, okay, hold on. How are you like almost failing Algebra 2? And what it turns out was, we kind of talked for a little bit, for him, when he was in algebra, he could see things like this, and the answer, x has to be what? What? 9, right? 9 plus 5 is 14. The answer to this one is a 5. So he could totally do that stuff in his head. The problem is, now we're getting to 3x minus 2 squared plus 17 equals 5. He never learned the steps to solving ones like this and this. He could just look at them. The multiplication ones, he could look at them. 3x plus 7 equals 24. he could look at it and get the answer. The problem is, once we gave him this in Algebra 2, he couldn't look at it and get the answer, and he had no skills for doing the steps. So I'm going to be kind of like homework Nazi. I'm probably going to start collecting your homework some days now and actually going through problem by problem the first part of this chapter, making sure that you're showing your work like this. Just because I don't want you to breeze through this class just because you're really bright and then find that you just totally get hammered later on in Algebra 2 or pre-calc. Fair enough? I just don't want you finding that you're just dying. So when we have this x plus 5 equals 14, looking at this baby right here, you look at what was done to the variable. We had the x, they, whoever they are, added 5 to the variable. What's the inverse or opposite of adding 5? Minusing 5. So in your homework, you will get full credit if you do minus 5. Show what you're doing to both sides. And then that leaves us just with an x on the left. Plus 5, minus 5 cancel. 14 minus 5 is 9. And I know a lot of you can just totally do that in your head, and this is wasting your time. But I just want you to learn the steps. So once you know the steps, you can do any problem, no matter how big and ugly and nasty I make it. You just apply the steps. So the next one, x minus 7 equals negative 2. What do we do to both sides? Nice. Add 7 to both sides. And once we do that, those drop out. X equals 5. And I think that's easier to do in my head than the answers people were given before. But those two make sense? Then if we turn the page, the steps are the same, even though we have fractions in this one. We look at what was done to the variable. We had m. They added 3/7. If we want to undo adding 3/7, we subtract 3/7. So we have this 5/7 minus 3/7. Just like before, this is going to just cancel out because they're inverses, leaving us m equals 5/7 minus 3/7, 2/7. And I'd be glad to go over adding, subtracting fractions with you if you're rusty. Should we do it all together, or maybe just help you one-on-one later? You're good? Okay. If you're not, talk to me in a minute and a half or less. All right, this last one, we subtracted 5 from p. The inverse of that is to add 5. And you get p equals 0. What I should have done for good modeling, what I'm supposed to do is say, hey, check your work. And if you want to check your work, it's smart to. A lot of us just kind of get out of the habit. But you could say, well, does that work? If I put a 0 in for p, 0 minus 5, just copying this thing here, equals negative 5. Is that true? Yup. Same thing, we could take the 2/7, we could put it in for m. And if I have 2/7 in for m, plus my 3/7, this part right there, does it equal 5/7? Yep, because common denominators, you need common denominators and just add the numerators. It gives you the 5.